Chemical formulae. When elements combine, they form compounds. For instance, sodium and chlorine react to form sodium chloride. During the reaction, a sodium atom loses an electron to form a sodium ion. A chlorine atom then gains the electron lost by the sodium atom to form a chloride ion. The ions then combine to form sodium chloride. The product of the reaction between sodium and chlorine, when represented in chemical symbols, is called the chemical formula. A chemical formula is a representation of a chemical substance using chemical symbols. It shows the constituent elements and the proportions in which they are combined. In order to write a correct chemical formula, it is necessary to know the symbols and valences of the elements that form the compounds. When writing the formula, always start with the element that is more likely to lose an electron, or electrons then follow with the one that gains. The chemical formula of a compound can be derived using the valences of the combining elements. To learn more about chemical formulas, let us look at the following examples. Magnesium reacts with fluorine to form magnesium fluoride. The atomic number of magnesium is 12. Therefore, its electron arrangement is 2.8.2, hence a valency of 2. The atomic number of fluorine is 17. Therefore, its electron arrangement is 2.8.7, hence a valency of 1. As we have already learnt, the valency of an atom is the number of electrons an atom loses or gains during a chemical reaction. Therefore, for magnesium to combine with fluorine to form magnesium fluoride, each magnesium atom requires 2 fluorine atoms. Accordingly, the formula for magnesium fluoride is MgF2. In the formula, the valences are interchanged and written as subscripts. Therefore, the formula is Mg1F2. When the subscript is 1, it is usually not written since the symbol represents one atom. Thus, the formula of magnesium fluoride is MgF2. Magnesium reacts with oxygen to form magnesium oxide. The atomic number of magnesium is 12. Therefore, its electron arrangement is 2.8.2, hence a valency of 2. The atomic number of oxygen is 8. Therefore, its electron arrangement is 2.6, hence a valency of 2. Just like in the previous equation, the valences are interchanged and written as subscripts. Therefore, the formula of magnesium oxide is Mg2O2. When the subscripts are the same, it indicates that the combining ratio is 1:1 and is therefore omitted from the formula. Hence, the formula of magnesium oxide is MgO. Carbon and oxygen react to form carbon-4 oxide. The atomic number of carbon is 6. Therefore, the electron configuration is 2.4, hence a valency of 4. The atomic number of oxygen is 8. Therefore, its electron arrangement is 2.6, hence a valency of 2. The combination of these two elements gives a formula of C2O4. The combining ratio is 2 to 4, which is simplified to 1 to 2. Hence the formula of carbon 4 oxide is CO2. Aluminium and oxygen react to form aluminium oxide. The combining power, valency, of aluminium is 3 while that of oxygen is 2. When these two elements combine, they form aluminium oxide, with the formula Al2O3. In deriving the formula for compounds involving radicals, the net charge on the radical is taken to be equal to the valency of the radical. For example, sodium has a valency of 1 while carbonate has a valency of 2. When combined, the chemical formula derived is Na2CO3, sodium carbonate. Where the formula of a compound contains more than one radical of the same type, the symbol of the radical is put in brackets and the number of radicals is indicated as a subscript to the right side of the brackets. Ammonium, with a combining power, valency, of 1, and sulfate with a combining power of 2, combine to form ammonium sulfate with a chemical formula, NH4,2SO4. When an element shows variable valency in its compounds, the valency exhibited is indicated in Roman numbers when naming its compounds. For example, copper 2 oxide, CuO, copper 1 oxide, Cu2O, iron 2 sulfate, FeSO4, iron 2 chloride, FeCl2, iron 3 chloride, FeCl3, sulfur 4 oxide, SO2, sulfur 6 oxide, SO3. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.